W is 500 pounds. And they asked us to find the tension in the normal. So we looked at the picture, so that was it. Given, find. Next, identify all the forces. We set up a table. We realized that there's a weight, but its magnitude and direction are given. The normal, the magnitude is not given, but the direction is given. Tension, magnitude's not given, but the direction is given. We know it's in the line of the rope. In the end, we found two unknowns, two equations, and Tara Lynn. Two unknowns, we knew we needed two equations, and we only needed one body. Is that correct?
Yes.
Because it's a 2D problem, we could get two equations for that. And then we drew our free body diagram. Santiago, all these forces come off the same point. What are those forces called?
Concurrent.
Concurrent forces. I just had a thought. Okay, so they're concurrent forces.
Why are they concurrent forces?
Yeah, why are they concurrent? That's fine. Come on.
I don't know.
Sam, why are they concurrent forces?
Because they're all at the same time.
They're all acting at the same point. So Isaac, what kind of motion could they create if they're all acting at the same point? Translational or rotational? Okay, the only time I could have rotational is if they're not acting at the same point, right? They're acting off the point. But if they're all acting on the same point, I can only move it this way. It's not going to rotate. So David, concurrent forces only can produce a what kind of motion? Translational, not rotational. Does everybody get that? Right? Okay.
So if they're, obviously they're kind of hitting this edges of something, is it that like that line of where they're hitting all those lines?
All those lines
It's
connect.
Okay.
Correct. So if we look out here, this whole weight, the 500 can come from the center, right? The normal's hitting it right here, but if you dashed it the direction, it's going through the center. And the tension, again, is maybe, I can't really tell whether it's connecting at the center or not, but again, it's the line of action. If the line of action of all the forces intersect at the same point, it could only produce translational motion. Okay. So not only is this flicking on and off, it's also going on. Okay, so then we went to a second problem. So number one, given, we read the stuff. Cable system, there's nothing in there that isn't in the sketch. They didn't give us anything in the words that's not in the sketch. So I just wrote given, sketch. And then find. We found what all the forces are in here. They're telling us that they want to know what the tension is in A, B, C, D, and the mass. Then we identified all the forces in the system and we set up our table. Tension A, tension B, tension C. The magnitudes are all unknown, but the directions are given. DJ. TD, initially we said we don't know it. TD is right here. But then in the end, we said we do know it. Could you explain to me why we know what that is?
Because tension D is the same thing as the weight.
Same as the weight. And if we wanted to do it statics-wise, we could draw a free body diagram, which I did on the left, showing how they are equal. I think I'm going to have to get some water. Hang on a second. But now we know for us, we do not have to draw that free body diagram. We are from now on just going to say, we know what TD is, and right next to TD, I wrote the weight. Or,
Would we have to write TD on the table, or can we just not write it? And
you still have to write it because it's a force that's given,
okay, so
right? Because in fact, they said up there, they want to know what TD is. If you left it off the total problem, then we wouldn't even be telling the person who designed the problem what TD is. force, we have to keep it as a force, we just know it.
To include it even if they don't ask for it. So like, we have to write TD and then
Good question.
show that,
Let's keep thinking about that every time we do a problem, and see if there's ever a force that we don't need. Most of the time, I don't wanna say all, because, there's always some exception. But, I mean, I probably would say you always have to list all the forces, because even if they don't ask you to find it, you're gonna wind up finding it, because in order to find something else, you have to find it. But let's see how we go along and see how that goes. Okay, you got all of these. So we have 4 unknowns, we need 4 equations. Larson, so how many bodies do I need to analyze?
2 bodies.
2. Okay, so what I want you to do is turn to the person next to you and talk about these free body diagrams. Is there anything missing on the free body diagrams? Also, talk about the directions of the arrows. I'll be right back.